Welcome to the third chemical lesson. This is also about reaction rates, but more about the factors influencing reaction rates. Different reactions happen at different rates. A match burning is finished in a few seconds. A car rusting can take decades to complete. So, as I explained previously, for this reaction, we have iron and sulfur, which is the reactants. Then they form iron sulfide, which is the product. So if you have a flask, in the beginning of the reaction, there is only iron and sulfur in the flask. Iron and sulfur needs to collide in a certain manner to form your product. Okay, so a prerequisite for a chemical reaction is that the two reaction molecules must collide with the correct amount of energy and orientation to change into the product molecule. That means that this reactant molecule and this reactant molecule must bump into one another with energy and with the correct orientation to form your product molecule. Now, factors influencing reaction rate. There are 6 of them, and we'll go through them slowly now, one by one. The first one is the nature of reactants. Different chemicals have different chemical properties and therefore different reactivities, like the match and the car in the beginning of the reaction. These will react at different rates because they have different chemical properties. The second factor is surface area, and this holds for solid reactants. If you have a bigger surface area, the rate of the reaction will increase. The reactant reacts faster when it is ground into powder form. Why? Because you are increasing the surface area. So you are increasing the amount of area where the two reactants can collide onto one another, and therefore the reaction rate increase. The third factor is concentration, and this holds for reactants in solution. The higher the concentration, the higher the reaction rate. The reaction rate will increase if you increase the concentration. And that is based on the collision theory. If there is more molecules floating around in the reaction mixture, the chance of them bumping into one another is more, and therefore the reaction rate is faster. Pressure. This is for gaseous reactants. A higher pressure will increase the reaction rate, and this is also based on the collision theory. More molecules, meaning more gaseous molecules floating around, will be able to bump into each other easier, and therefore the reaction rate will increase. Temperature. A higher temperature will increase reaction rate. Why? Because a higher temperature would increase the average kinetic energy of the reactant molecules. Kinetic energy means they move faster. If cars drive faster, you have more collisions. If chemical molecules have higher kinetic energy, they move faster in the reaction mixture and they bump into one another more, and therefore the reaction rate is faster. So higher temperature, increase reaction rate. Then you can add a catalyst. A catalyst is just something you add to your reaction mixture. It remains unchanged, but it increases the reaction rate. How? It increases the reaction rate by lowering the activation energy of the reaction. Now, activation energy is the minimum amount of energy required for the reaction to happen. So, here's a graph to explain it a bit more clearly. you need a certain amount of energy for the reactants to bump one into one another to form your product. Now, if this line is your activation energy, usually, if you add a catalyst, that line will be lower. You will need less energy, and therefore the reaction rate will increase. So, example 1. Consider the chemical reaction represented by the equation below. Which one of the following changes will increase the rate of production of CO2? That is another way of saying which one of the following changes will increase the reaction rate, because the rate of production of CO2, which is a product, is an increase in the reaction rate. So let's go through them one by one. An increase in pressure. Is there a gaseous reactant? No. Calcium carbonate is a solid. Hydrogen chloride is in solution. So there's no gaseous reactant. So an increase in pressure will have no effect. An increase in the mass of calcium carbonate, that would also not have an effect, except if they increase the surface area. But that means that they have to ground the calcium carbonate. An increase in the volume of hydrogen chloride, that would also not increase the reaction rate. You would have to increase the concentration of hydrogen chloride, not the volume. So D, an increase in concentration of hydrogen chloride. Yes, that would have an increase in the molecules, and that would have an increase in collisions, but then have an increase in the rate of the reaction. So the correct answer is D. Example 2. A plus B gives you AB. If you wanted to increase the rate of the reaction, which of the following would you do? Decrease the temperature? No, that would decrease the rate of the reaction. Grind A into a powder? Yes, that would increase the surface area of the reactant, and that causes an increase in reaction rate. Let's just look at the other one. Decrease the pressure of B. No, B is a gas, and therefore an increase in pressure would give you an increase in the rate of the reaction. Therefore, the correct answer is B. Grind A into a powder. Example 3. Here we have 5 different reactions taking place. 3A says, complete the table by calculating the rate of the reaction. The rate of the reaction is the mole of the reactant used divided by reaction time. The table gives you the mole of reactant used, and the table gives you the reaction time in seconds. So you can easily calculate the rate of the reaction of these 5 reactions. You just take the mole divided by the time, the mole divided by the time, and there's the answers. Now let's look at number B. Which reaction is the fastest? The fastest reaction would have the highest reaction rate. So which one of these has the highest number? And that would be reaction number 5. Which reaction is the slowest? That would be where the reaction rate has the lowest number. And that would be reaction number 3.